Hey there, and thanks for tuning in. Welcome to a new episode of the Technology Addicts podcast by Avnet Abacus. Rising expectations in terms of sustainability are heavily impacting the electronics sector, and building a smart, sustainable future will require electrifying virtually all aspects of the economy. But with demand for power rising year after year across applications, the task won't be easy. To tackle this ambitious goal, we need to harvest energy gains wherever they're available, and that's why we made efficiency the focus of this first episode in our Smart Energy series. So stay with us and learn why high-power, high-frequency technology is generating so much interest and why it could be a game changer in optimizing energy management in power generation, transportation systems, and urban centers. We'll also explore technological hurdles we've had to overcome to get to where we are today and venture into the uncharted terrain of future challenges and opportunities. And here to discuss this with us is Cathal Sheehan, Senior Technical Market Manager at Borns. Hi, Cathal. Welcome to the podcast.
Hi, Jan. Thanks for having me.
Cathal will be joined by Sarah Gaemi, Director of Technical Development at Avnet Abacus. Hi, Sarah. It's great to welcome you back to the studio.
Hi, Jan. It's a pleasure for me to be here again.
So, Sarah, let's start with you. First, can you tell us why is there so much interest in high-power, high-frequency technology?
Yes, this is a very interesting question. Let me start from the beginning and how the story started. The story started as we recognize we are facing with the global warming and need to get control of the consequence crisis. Since 1990, there are various directives to support limiting the rise in the global average temperature to 1.5 degrees centigrade and increasing efficiency, of course. In the current climate change conference, which ends today in Dubai, 118 countries have signed up to triple renewable generation capacity and doubling the rate of efficiency programs by 2030. So the energy efficiency is an important topic, which is reflected also in the electronic components. High power, high frequency technologies are employed for efficient energy conversion in power electronics. Higher frequencies enable the design of smaller and lighter power electronic components, reducing energy loss, and of course, improving overall efficiency. This also applies to high voltage application. The higher the voltage, of course, the lower the current of the power transmitted, and the lower the copper losses due to the heating of the cable. This reduces the weight and the size of the required cables and, of course, electronic components, and lead to more energy and cost efficiency. So it is all about energy efficiency at the end.
Okay, so Cathal, could you briefly explain what's so unique about the high-power, high-frequency solutions? I think Sarah's touched on a lot of points. Maybe get into some more detail on how they work and under what circumstances they're the most advantageous.
Yeah, sure. I suppose as Sarah was talking about high power, high frequency, one of the key drivers would be swap, right? Size, weight, and power. And how would you achieve that? You would use the latest technology in switching devices. So these would be also known as wide bandgap switching devices. So they can operate at frequencies, let's say anything up to 500 kilohertz, depending on the type of technology you're using. And this has been enabled over the past, let's say, 10 years, and it's becoming very much mainstream now. And that allows you to basically miniaturize, downsize, integrate, reduce the size, the weight of the device, and maintain power and high energy densities. When you scale up, it also allows you to bring the cost down, so it makes it more attractive on a larger scale.
Okay. And Sarah, as technical director at Avnet Abacus, you have unique first-hand insight into market trends as they unfold. So is the increase in demand for high power, high frequency components, is that something you can clearly see in your customers' order books?
Oh, yes, definitely. So when we take a look at our booming applications like EV charging stations, which is there to overcome range anxiety, of course, or the electrification of the cars, which supports reaching our zero emission goal, or further growing integration of renewable resources for having clean and independent energy sources. So all of these applications, and of course, we see more and more the need for high power and high frequency electronic components as they support increasing energy efficiency in our smart energy system.
Cathal, Borns is well known for its power conversion systems tailored to a broad range of markets. Can you tell us, how can Borns support customers seeking to maximize the power efficiency of their solutions?
Borns is a global supplier of magnetic components, and not just magnetic components, resistive components and semiconductors as well, used quite a lot in converters for applications in across the board, industrial, automotive, consumer segments. And we do a lot of customized magnetics as well through our R&D teams. And so we would work closely with customers to try and, get to the maximum efficiency possible through the use of customized designs.
And considering smart transportation systems, which are expected to be the largest contributor to increased energy demand in advanced economies, what opportunities specifically in this area do you see for high power, high frequency solutions to contribute to optimizing their power efficiency?
I mean, I suppose it goes back to the use of wide bandgap. So that enables high power, high frequency, such as in gallium nitride or silicon carbide, for example. And this allows, for miniaturizing, integrating hybrid inverters, for example, which are becoming more popular because they have lower losses, anything above 50 kilohertz. Now, of course, you have to balance that with cost. I'm not saying that silicon goes away. There is a cost thing as well. So it very much depends if you want the superior performance with the very high efficiency, or do you want to go maybe with a lower efficiency, but maybe more focused on the costs.
And where else should we expect these solutions to deliver benefits? Are there any other sectors, any other markets, Sarah? What do you see?
Of course, these solutions are not set to the transportation system. They are also an integral part in the integration of renewable resources to our smart energy system. So high power wind turbines or solar farms need advanced inverters, which uses the high frequency technology in converting the power with high efficiency. These technologies are also playing a crucial role in the integration of energy storage system in the future smart energy, which we are already in that future. We see the integration of these components in the system and also the usage of those in the system. So in summary, the high power, high frequency solutions offer a range of opportunities to enhance power efficiency in renewable resources and smart urban environments, definitely contributing to more sustainability and technological advanced energy landscape.
And Kyle, do you have any examples of real world projects, maybe providing some insight into what type of efficiency gains can be expected?
Yeah. So, for example, let's say if we're talking about transportation, in onboard chargers, let's say 11 kilowatt onboard charger, the typical target efficiency would be 99% with the latest technologies, which is something which wouldn't have been possible even 5 years ago. And then on the renewable energy side, hybrid inverters using gallium nitride at 500 kilohertz, we're seeing more of that as well. And again, they're aiming for 98, 99% efficiency. But it is a challenge for us as a supplier of magnetics to meet those goals, because even though on the face of it, the geometries come down, you still have a lot of things to deal with, like, for example, losses in the copper, losses in the core. So it's still a challenge to kind of keep up with the fast moving pace of semiconductors.
Sarah, do you see any other areas, smart cities, for example, in domestic applications? Does anything else come to mind?
Yeah, I mean, when we are talking about smart cities, obviously the EV charging stations are also another area. We are talking about high frequency, high power for DC fast charging stations. So also integration of energy storage system into those DC fast charging stations. So all in all, it is about having more efficiency and using high power, high frequency solutions to create those energy efficiencies in those solutions.
Kyle,
do you have an example of like a smart city application that you would like to highlight?
Yeah, I guess for us, it was very much working on the moment on a hybrid inverter for solar. It's working at 500 kilohertz gallium nitride, but it is a challenge for magnetic suppliers to try and, because obviously the gallium nitride, is very efficient, but then the losses out of the magnetics have to be low as well. And that's a real challenge, trying to keep up with that. And we're trying all kinds of different things. I think what's very important is the magnetic materials, the soft magnetic materials for the cores are really important. It's something we're actively involved in, is trying to develop materials which have very low power loss densities at higher frequencies.
So, Sarah, where are we headed in terms of voltage that we're aiming for, and where do you expect us to top out?
Now, well, it depends which application we are talking about. So if we talk about the high voltage DC transmission lines, even we have reached 1100 kilovolt link, which is existing in China since 2019. If we stick to our applications in the smart city area, smart EV charging, we have already the 800 volt architecture for the electrification. We have an exception with Lucid Motors, which is about 900 plus architecture, which they are trying to differentiate themselves from the other manufacturers. At the end, the high voltage serves higher efficiency and better cost. However, we need also take into consideration that the higher voltages bring challenges related to safety, insulation, and also compatibility with the existing technologies. We have heard also from Katal the challenges we have in a design, and specifically also on the magnetic side. It is not an easy thing to overcome it, but I believe that the future technological advances will shed some light here.
Kyle, can you talk about where you see the most innovation happening right now to try and push the limits further at Borns?
Well, I think magnetics is always kind of find it hard to keep up with semiconductors because the frequency, the materials, the soft magnetic materials, they have eddy currents, which increase the losses in the soft magnetic cores. Problem is, the higher the frequency, the inductance tends to go down. If the inductance goes down, the magnetizing current increases. The magnetizing current increases, the flux density goes up. And if the flux density increases, then at a particular frequency, the actual heat generated in the core goes up. So it's trying to find those materials which are able to have low losses as the frequencies go up. So that's kind of a real challenge for us, but that's kind of where we're trying to, Borns is working on trying to see what can be done to come up with new materials which have lower losses as the frequency increases. So I think for us, it's very much the innovation has to be in the material side of things.
Are there other avenues that are being explored to further increase efficiency? So we've focused very strongly on high power, high frequency. Are there other major strategies that are being applied or pursued to try and contribute to that end goal of more efficiency in a smarter, sustainable future, basically?
Yes, I mean, apart from Borns, there are different topologies being used. So you've got hard switching going on and you've got soft switching. So improving the soft switching is very important. And one of the things that we know as well is if you have a kind of a bridge type technology and it's like an active bridge, you actually see a lot more losses in the magnetics than if you use a kind of a more resonant type approach where you have a more sinusoidal wave going through the magnetics. So we see a lot of innovation in the actual topology itself of the converter to kind of improve the losses both in the semiconductor and in the magnetics as well.
Sarah, is there anything you'd like to add?
Well, Kahal explained a lot on the inductor side about the designs, materials, topologies that they are existing to increase the efficiency on the inverter side. I would like to touch upon maybe on the different topics that also includes energy efficiency within the smart future. For example, one of them is about demand response. So we are also trying to use smart technologies to adjust energy consumption based on the real-time demand and supply conditions, which is one of the topics we have in the smart grids based on the, let's say, the not consistent availability of renewable resources in the grid. We can also talk about the predictive analytics, like using AI and machine learning algorithms to predictive maintenances, load forecasting, and optimization of energy generation and, of course, consumption. And also, not to forget about the energy harvesting topic, which is coming more and more on the design of electronic solutions and products coming to the market.
Yeah, thank you. So you could imagine that a lot of customers are trying to pursue these 99% conversion efficiencies, but what are the main challenges that customers developing smart energy solutions may face when transitioning to these high power, high frequency technologies? And what does Borns do to support them, or what can you offer?
So I suppose, as Sarah alluded to earlier, that there's of course the electronic design side, but there's also the mechanical side. When you're working at high voltages, it's very important that you follow the standards in terms of the insulation of the magnetics. So, for example, you could have a system with a working voltage of 1,000 volts, even though your magnetic is only designed to operate at 50 volts or something like that. So you have to design the transformer so that if it ever gets hit with 4,000 volts, the insulation won't break down. So you have to mechanically design the transformer in a way that it meets the rules and regulations. So in that sense, we provide a lot of support to help customers meet those requirements, helping them with the mechanical design and the selection of the materials so that they meet the insulation requirements. And a very important test as well is to guarantee that the insulation won't degrade over time. So there's a couple of tests that have to be done. One of them is called a partial discharge test, which basically checks the health of the actual insulation material itself. It does a certain test. It works out how many coulombs are stored inside the insulation material, and that is an indication of how healthy it is. So quite a lot of customers, especially those involved in making, let's say, switchgear for microgrids, they are operating at very high voltages, and they would expect the magnetics to be able to have an insulation which is very robust and is able to last maybe 10, 20 years without failure. So that's something that we do a lot in terms of supporting customers with that and the testing.
And Sarah, adopting high power, high frequency technology will be keeping product manufacturers busy for some time. So how can Avnet Abacus help to make the process as efficient and as smooth as possible?
As one of the pioneer distributors in demand creation activities, Avnet Abacus provide expert technical support to help manufacturers understand the specifications, capabilities, and integration requirement of high power, high frequency components based on the market feedback. Obviously, we are working with a lot of customers, and we can give the feedback back to the manufacturers about what is needed in a market, how we can come up with the better solutions to the customers. On the other side, we also help our customers to design these products in their solutions and accompany their product development process from idea to reality to make also their time to market and their product introduction to the market in a much more efficient way.
All right, great. So at the end of each episode of The Technology Addicts, we ask our guests the same question. What would you say is your current technology addiction? And that could be anything from a gadget that you recently bought to an entire field of technology that's captivated you. Maybe Cathal, we can start with you.
Yeah, and for me, it's all about the science behind magnetic materials. So it's a really fascinating science. You know, how it actually, you create magnetic fields and how you can create the characteristics that you want, permeability, you know, the geometries, a fascinating field. So that's something which I'm passionate about at the moment.
Excellent, thank you. And Sarah, what about you?
Yeah, this is a very challenging question, as I have been replying to the question in different episodes. I'm not sure if I'm allowed to repeating this to just not bore the listeners with the same answer.
Pick your favorite, I guess.
The big addiction is going to be also to keeping up with the new technology and disrupting technologies coming, just following up different new stuff coming into play and wondering how our life is going to look like in the next 10, 20 years.
All right, that's great. So we'd like to thank Cathal and Sarah for joining us for this episode of the Technology Addicts podcast. And dear listeners, if you'd like to get in touch with Cathal or with Sarah, you can reach out to them and you'll find all the contact information in the show notes. And to everyone listening, thank you for joining us today and stay tuned for the next episode of the Technology Addicts.